Hi, this is Brett Sackett with Pasco Scientific, and I'm here with
JJ Plank.
And we're going to do some physics and investigate an Ohm's law application. So what I have here is a simple circuit with a 10 ohm resistor and a variable power supply that I've put together using this bank of D-cell batteries and a potentiometer. And what we're going to do is we're going to vary the potential and measure that with our new wireless voltage sensor. And then later what we're going to do is we're going to investigate the relationship between voltage and current with our new wireless current sensor. And so what I've done there is I've hooked up the wireless voltage sensor in parallel with the resistor to measure the voltage drop across the resistor.
Okay, great. So I've got the software all set up. We're going to be using Pasco Capstone software to take a look at the data that's going to be recorded from that wireless voltage sensor. So I'm going to go ahead and click record here and we can see the live reading.
All right, so right now I'm going to start changing the potentiometer here. You can see that the voltage is changing.
Right, so Brett, you mentioned that you're using a variable power supply. The voltage that comes out into the circuit can be adjusted by simply just turning that potentiometer.
Yeah. So what we're going to do now is we're going to break this circuit right here, and we're going to take our wireless current sensor and we're going to put it in series in our circuit, and that will allow us to measure the current. And so anytime you want to measure current in a circuit, you need to break the circuit and put the wireless current sensor in series. And so now we have our simple circuit is complete with a voltage sensor and our wireless current sensor.
Okay, and Capstone, as we saw before, is already set up. I have it configured here to display the data from both the voltage and current sensor simultaneously in this graph. So on my y-axis we see voltage, and on my x-axis we see current. So I'm going to go ahead and click record, and Brett's going to adjust the voltage applied across that resistor, and we can see how the current in the circuit responds.
That's right. All right, so I'm changing that slowly, and you can see that as the potential drops, so does the current.
Yeah, and it looks very much like a straight line here, which indicates there's some proportionality between voltage and current, and we can determine what that proportionality constant is using a linear fit. So I'll go up here and turn on a linear fit, and we can see here in our graph, actually, you know what, let me go ahead and click stop too. In our graph, we've got a great correlation coefficient here, indicating that there's a good fit, a good linear fit here, and the slope's equal to 9.92. That's our proportionality constant. It turns out that the proportionality constant also just about matches the resistance of that resistor.
Of a 10 ohm resistor. Now, it's linear. We know that this resistor here is an ohmic material, and those generally produce linear response curves. But what if we had something that is not linear? And so a light bulb is going to behave slightly differently. All right, so here what I've done is I've connected a light bulb and replaced the resistor. And what we're going to see here now, we're going to collect a new run, and we're going to see that this behaves a little bit different. And so what I'm going to do is I'm going to change the voltage back and forth. And you can see here our response curve isn't linear.
Yeah, it's got a little bit of a curve to it. And it turns out that as the filament in the bulb heats up, the resistance of the filament changes. So as we increase the voltage, more current flows through the filament, which in turn heats it up and subsequently changes its resistance. So our curve here, our voltage versus current curve, has a little bit of a
hysteresis.
Yeah, a little bit of hysteresis and a curve to it, as you can see.
Yeah. All right, thanks for watching. So that's our investigation of Ohm's law with our new wireless current sensor and wireless voltage sensor.
And thanks for joining us.